In this lesson, we're going to be looking at solving rational equations. So really the sense here is that we're solving equations that have fractions in them. So if I consider this first example, this is one that we should already know how to do, and we're going to look at something a little bit more complicated after this. But anytime we're dealing with an equation and we have fractions involved, the best thing to do, for example, in this one, you could start distributing here and distribute here and then deal with a bunch of fractions along the way. But the best thing to do is eliminate fractions by multiplying through by the common denominator. So as I look across these fractions to see the 2 and the 3, the common denominator here is going to be 6. So that means what I should do is I should multiply each side of the equation by 6. So I multiply each side by the common denominator. And now I distribute this 6 on each side. So here I distribute it to this first piece and to this second piece. Here there's just one piece to multiply it by. And so what happens here is the 6 and the 1/2 end up giving me a 3, so I end up with 3 times the x plus 5 minus the 24. Over on the other side, I distribute, that's going to give me a 2 times the 2x minus 1. All right? And so what happens here when we multiply through by the common denominator, all the fractions go away. All right? And that's the key to this thing. And so now from here I can finish solving this thing. I'm using my distributive property a little bit more. I got a 3x plus 15 minus 24 equals a 4x. Let me try that again. 4x minus 2. I combine like terms over here. That's going to give me a negative 9. Now I have to get my x's all on the same side, so I'm going to subtract the 3x from each side. So I end up with a negative 9 equals x minus 2. And I add the 2 to each side. So I find that x equals a negative 7. But again, the thing that made this problem much easier is getting rid of those fractions, all right? So when we're looking at rational equations, all right, it looks a lot more complicated, but the fundamental rule here is the same. I want to get rid of fractions, and the easy way to get rid of fractions is to multiply through by the common denominator. So as I look at these fractions, if I look at all the factors that I have here, I've got the x minus 2, the x minus 1, and the x minus 1, x minus 2. Remember, when we get common denominators with these things, I basically just make sure that each denominator has all the same stuff. So if I started compiling all the different factors that each of these denominators has and wrote out what I would have if I gave all of them the same thing, each of them would need an x minus 1, and each of them would need an x minus 2. Okay, so when you look at that first fraction, it wants an x minus 1 to get the common denominator. The next one needs the x minus 2 to get the common denominator. The last one doesn't need anything. So my common denominator is the x minus 1, x minus 2. All right, so here we're identifying the common denominator. And now what I'm going to do to eliminate fractions, I'm going to multiply each side of the equation by this common denominator, by the x minus 1, x minus 2. Same thing on the other side. I'm going to multiply by the x minus 1, x minus 2. Because whatever I do to one side, I have to do the other side. And now it becomes my distributive property. And keep in mind, I'm taking this whole chunk and distributing it to this guy. And then I'm taking this whole chunk and distributing it to each of these fractions. Okay? So let me write this out. It's going to look a little bit ugly at first, but then it's going to become very, very simple. So this first one leaves me with an x minus 1, x minus 2 times the 3. So it's 3 times those things all over the x minus 2. Equals. Over here, when I do 1 times that, that's going to give me an x minus 1, x minus 2, all over the x minus 1. Plus, here I'm going to have a 7 times the x minus 1 times the x minus 2. And notice, I don't actually multiply any of this out. I leave it in factored form because the idea is that when we multiply through by the common denominator, we eliminate fractions, which means every single one of these is going to reduce. Look at the first one. The x minus 2's cancel. The next one, the x minus 1's cancel. The next one, the x minus 1's and the x minus 2 cancel. So watch what happens. Look at what I'm left with. Notice this first one is no longer going to be a fraction. I'm only left with a 3 times x minus 1 equals. Over here, this next fraction, I'm only left with the x minus 2. Plus, the next fraction, I'm left with a 7, and that's it. And so when we look at that original problem, we kind of take it to a place that looks a little bit messier, but as things start to cancel, look at how clear this thing becomes. All right, so all the fractions are now gone. Now I'm solving the linear equation. Here I distribute. Over here I'm going to combine like terms. And so what I'm left with here is I end up with a 3x minus 3 equals, this little mark in the way, let me move that. That's going to give me an x plus 5. And now I'm going to subtract the x from each side. Take this guy off to the side. That's going to give me a 2x minus 3 equals 5. I'm going to add the 3 to each side. And now I divide by the 2. Keep running out of space. So this is taking up a little bit of room. All right, it looked a little bit complicated at first. But now look at how simplified this is. Okay, x equals 4. And the last thing we need to do is we need to check to make sure this isn't one of our domain restrictions. So as you look through at these denominators, here I'd have a domain restriction that x can't equal 2. Here x can't equal a 1. And here x can't equal 1 or 2. 4 is not one of those, so 4 is an okay solution. So x equals 4 is my solution for this one. So make sure you check for extraneous solutions. If I look at the next one, again, this 2 here, that's like 2 over 1. So as I start to identify the common denominator, really this one should be pretty straightforward. The common denominator is x minus 1. If I look at all the factors that are listed and just list all the factors, and that's the easiest way to do this. You just take a list of all the factors. I've got a 1 and I've got an x minus 1, which that 1 doesn't do anything. So the common denominator is the x minus 1. So I'm going to multiply each side by the x minus 1. Whatever I do to one side, I have to do to the other side. And so now as I distribute this thing, again, I have to distribute it to each of the pieces over here, each of the fractions. Over here, there's only one fraction. So here's what it gives me. It gives me a 3x times x minus 1 over the x minus 1. Plus, that's going to be a 2 times x minus 1 over 1, which I don't need to write, over 1. And then here it's the 3 times x minus 1 all over x minus 1. All right? So now I reduce each of these fractions. Here these guys cancel, here these guys cancel. And so what I'm left with when it's all said and done is a 3x plus 2 times x minus 1 equals 3. All the fractions have disappeared. Now this is a very simple equation to solve. I distribute and combine like terms. That's a 3x plus 2x minus 2 equals 3. That's a 5x minus 2 equals 3. And now I finish solving from here. I add the 2 to each side. So I find out that 5x equals 5. And now I divide each side by the 5. And I find out that x equals 1. And at first it seems like that's great and that's a wonderful solution. But look at the denominators you had in the original problem. See, the domain restriction that this thing right here would give me is that x cannot equal a positive 1. And so what that means is that x equals 1 is an extraneous solution. I can't equal that. And since there's no other valid solutions available, the answer here is no solution. Okay? So make sure you check your solution against what the domain restrictions would be. Okay? If I look at this one, again, this time I can't really see the common denominator the way this is written. I need to factor these denominators completely. This one's already factored. This one's already factored, but then this one over here, I can factor this into an x plus 1, x minus 1. All right? Just like when we found common denominators for addition and subtraction, we had to factor so we could identify all the factors, the common factors and the factors that each one needed. I got to do the same thing here. So now if I make a list of the factors, here's an x plus 1 and x minus 1, and this has one of each. So the two factors that are really listed here are the x minus 1 and the x plus 1. If I were to create common denominators here, it would be x plus 1, x minus 1. All right? So now I'm going to multiply each side of this thing by the common denominator. So I multiply this side by the x plus 1, x minus 1. I multiply this side by the x plus 1, x minus 1. And now I just start distributing. So over here I have to distribute this to each of the fractions. Over here, I just distribute it to the one fraction that's listed. So here I get a 4x plus 1, x minus 1, all over x plus 1. Right here, I get an x plus 1, x minus 1, over an x minus 1. And over here, I get a 3 times x plus 1, x minus 1, over x plus 1, x minus 1. Now I'm just going to simplify. I'm going to reduce each of these fractions. Here the x plus 1s cancel. I wanted a different color for that. So you can see me crossing it out. There we go. Here the x minus 1s cancel. Here the x plus 1s and the x minus 1s cancel. So here's what I'm left with. Okay, so I had a step or two that made it look a little bit messier, but now it's all going to get cleaned up. This first one, I'm left with a 4 times x minus 1 minus, here I'm just left with an x plus 1. Over here, I'm left with just a 3, everything else canceled out. So look at how much simpler this thing is now. Now I'm going to finish solving this thing. Here I distribute. That's going to give me a 4x minus 4. Here I'm also going to distribute. I'm going to distribute the negative 1 that's here. To get rid of the parentheses, that's going to be a negative x minus 1. And now I combine like terms. That's going to be a 3x minus 5 equals 3. I go ahead and I add the 5 to each side. So I get 3x equals 8. And now I divide each side by the 3. And again, I look back, I check it against what would be the domain restrictions. Here the domain restrictions would be positive 1 and negative 1, which this is neither, so this is a valid solution. Okay? If I look at one more, as I look at this thing, I might look at this and realize that they don't have anything in common. I can't factor this. But if you run into a situation where we have this, I could multiply by the common denominator, and that would be fine. In this case, the common denominator would be x plus 4 to x minus 1. It would have to be each of those factors. If I multiplied each side by that, that would be fine. I could do that. Let me show you that real quickly. What happens is on the first side, the x plus 4s cancel. On the second side, the x minus 1s cancel. And so what I have here is I have 2 times the 2x minus 1. Over here, I have 5 times the x plus 4. And really, that's the same result I would get had I cross-multiplied. All right? So if you recognize that you just have 2 fractions equal to each other, and that's the only 2 pieces you have, feel free to cross-multiply and make this a lot easier on yourself. So here I do the 2 times the 2x minus 1, and then the 5 times the x plus 4. All right? So cross-multiplying for this one is probably just a little bit of an easier option if I were to get rid of some of this stuff. There we go. We can kind of see cross-multiplying and how simple that is. I multiply this by this. Here it is. And I multiply this guy times this guy, and here it is. All right. So again, don't forget about simple methods like cross-multiplication, especially when you have 2 fractions equal to one another. So now let's finish solving this thing. I go ahead and distribute. That's going to give me a 4x minus 2. Over here I distribute, and it gives me a 5x plus 20. And now I've got to get all the x's on the same side, so I'm going to subtract the 4x. That's going to be an x plus 20. And now I'm going to go ahead and subtract the 20 from each side. And I find out that x equals a negative 22. Okay? And so I check. I look at this. If I look at the domain restrictions that would result from each of these denominators, I'd find out that x can't equal a negative 4, and x can't equal a positive 1/2. And since that negative 22 is neither of those, it means that this is a valid solution. Okay?